Okay. Hello, good afternoon, all. My name is Krishna Sharma. I completed my master's in Jadavpur University in 2020 under guidance of Professor Dr. Dipankar Das. He is the co-author of this paper, and our paper name is Leveraging of Weighted Ensemble Technique for Identifying Medical Concepts from Clinical Text at Word and Phrase Level. So the main objective of our paper is to identify the medical concepts from a given sentence. So we will discuss in subsequent slides, right? So before that, we will introduce our context of the paper. Like medical text processing is a very popular task in NLP. We have developed one state-of-the-art tool for, for processing the unstructured data. Then our main objective is to identify the medical concept from a given sentence. We will discuss this process in the subsequent parts. So nowadays people are relying in electronic data and number of active internet users is increasing. So in case of medical field, there are lots of data available, but not that much development is there. So we need a state of the art tool for this processing of this data, right? So now the main challenges in medical text domain is we are not doctors, right? So we have limited knowledge in the medical text, so we have to learn some concept over this medical text, and we have to annotate the data, and we have to create a noise free corpus for that. So it is one challenge in our paper also. And also we have pre-trained our own word embedding model here. We didn't use any other pre-trained model, so we have created our own word embedding model using word2vec. Then we have extracted text from PDF. So sometimes extracting text from PDF is also a challenging task. So and also the dealing with unstructured data is also a challenging task. Now to introduce our concept identification module, we can say like that if we will give an input to our system, like penicillin is useful for infection caused by bacteria. Our system should give an output like this. Penicillin is a medical term, then infection is a medical term, then bacteria is a medical term, and rest of all are non-medical terms. So this is our main objective of this paper. Now, the concept identification, a medical entity can be like a single word and multi-word expressions. So we have to deal with that. We have used word2vec embedding model. We have used some machine learning and also one deep learning model to classify our text. Okay, then we have used a phrase identification module, and then we have used ensemble module to increase our performance, and ablation study for reducing the length of the feature vector. Now the word2vec word embedding model. So we have to train a word embedding model, so we need lots of text over there. For this reason, we have extracted 170 medical books of various domains such as anatomy, internal medicine, physiology, biochemistry, etc. Then we have extracted text from these PDF files using Python Tika library. We have used GenSim for this Python, GenSim for this word2vec model. We have set minimum count as 1. We have used skipgram for the word2vec. And our embedding model will return feature vector of length 100. Now the data set, there is a popular medical dictionary, that is Black's Medical Dictionary 41st edition. We have extracted 34,666 sentences from the medical dictionary. These sentences were split into 27,383 sentences, and then as a training data, and 7,283 sentences as a test data. The description of the data is then following. You can see that. Now, the training process. So we have used 5 machine learning algorithm and one LSTM or one deep learning algorithm, that is LSTM. So why we have used this 5 machine learning algorithm? Because we want to compare our algorithms, our this machine learning algorithms with the data, and we will find that which algorithm is working fine in our data, right? So yeah. So we have used scikit-learn Python library for this machine learning algorithms and Keras for LSTM. Now the observation. Here comes the main point. Medical phrase identification is a challenging task because identification of medical phrase is dependent on context. Sometimes non-medical words also invokes the same sense of medical concept. Like you can see here, like Indian Medical Association or red bite fever, like these types of medical phrases have non-medical terms in it, right? Like Indian is not a medical term, association is not a medical term, but as a phrase level, Indian Medical Association is a medical term. So these traditional machine learning algorithms like SVM, K nearest neighbor, they are not able to observe the context, right? Right. So we will discuss it into 2 instances. Like the first instance is Indian Medical Association issued red alert for coronavirus. Like we have a sentence like this, and our model should predict Indian Medical Association as a medical term and coronavirus as a medical term. But in the next instance, we can see here that National Indian Association was founded in 1876. Here you can see that if our SVM or any traditional machine learning algorithm is giving Indian as a medical term, that means whenever it will see Indian, it will give as a medical predict the Indian as a medical term. So that means in instance 2, we also can see like that Indian association can be predicted as a medical term, but it is not right. So this is so because machine learning classifiers mentioned before cannot observe the context, but LSTM can observe the context. Now we have modified our traditional machine learning algorithm using the phrase identification module, and then we have also trained our LSTM, and then we have compared the performance of our traditional machine learning algorithm with the LSTM. Now the solution, what can be the solution here? So the solution we have proposed is like Indian Medical Association used red alert for COVID-19, suppose like that sentences. For first we will pass these sentences to our phrase identification module. Then our phrase identification module will classify or extract the phrases out of the sentences. Like here you can see that Indian Medical Association is a phrase. So we have to extract the phrase first. Then we have to give the phrase to our machine learning algorithm. And if there is a medical term in our phrase, then we will declare the medical phrase. We will declare the phrase as a medical phrase. So like you can see here, Indian Medical Association, there is a term called medical. So it is a medical term. So our phrase Indian Medical Association is a medical concept here. But if you see here, like National Indian Association, National Indian Association was founded in 1876. So here you can see that in this phrase National Indian Association, there is no medical word here. So our algorithm will say that there is no medical term here. So we can solve the problem which we have described in this slide. Like sometimes Indian is in medical concept, sometimes it is not. So our traditional machine learning algorithm cannot detect the context. So we have added a new feature, that is phrase identification module before the classification will be done. So this is one thing. Now we have to discuss about our phrase identification module. It is a rule-based module. So we have used NLTK Python library for extracting phrases. So we have defined some rules for phrase identification. Then in the first pass, our system will extract the medical phrases. In the second pass, our system predict those terms are medical or not. Okay. Then there is an example of the extraction of the phrases. Like you can see here, we have extracted the phrases using the pause tag, that is you can see here like JJ or DT, like the pause tag. These are available in the NLTK library. So noun, pronoun, pause tag, parts of speech tag. Here you can see the our module will create a tree out of it, and it will classify. It will extract the phrases out of the sentences. Okay. Then there are certain rules we have declared for the medical concept, medical phrase extraction. You can see here there are more rules here. So yeah, then comes LSTM classifier. Till now, which we have done is like we have created our own phrase identification module. Then we will pass these phrases to our traditional machine learning algorithm. Then it will predict our phrases out of these sentences. Then we have used the LSTM classifier. We know that LSTM can detect the context in the text. So apart from this 5 machine learning algorithm, we have used one deep learning classifier, that is LSTM. We have used the distributed character embedding with output dimension of 20. Then first layer has the 64 unit of LSTM with recurrent dropout is 0.1. Then second layer is 256 having the same dropout of 0.1. We have used Adam optimizer and then cross entropy loss function for the loss calculation. And these parameters, these hyperparameters, were tuned, and we have found that these things are best performing in our dataset. So we have using the grid search method here, so that we can found that which parameters are best in our dataset. Then you can see the precision recall F score for all the dataset. All the classifiers. So here you can see that SVM and LSTM, SVM using the phrase identification module is outperforming LSTM in some cases. So you can see here. Okay. Then Ensemble module. So what is the Ensemble module here? Like in a machine learning, Ensemble is a technique which uses multiple learning algorithm to obtain better performance, which could not be obtained from any of the single learning algorithms alone. So we have ensembled the four classifiers, because out of these 6 classifiers, 4 are good performers. So we have selected SVM, KNN, LSTM, and logistic regression here. So we will apply Ensemble with them. So the algorithm says that there are n number of classifiers, and we will assign certain weights to every classifier. Like you can see here that alpha and omega are the classifiers, and omega are the weights. So now we will summarize this, and we will also declare one threshold, that if the summarized value is greater than the threshold, we will classify it as a medical concept, right? So there are a snapshot of various weights and the threshold here. So out of there is a best performer weights, that is 0.3 into SBM, 0.3 into KNN, 0.25 into LSTM, and 0.1 as logistic regression, and the threshold is 0.65. So we have found that these uh, weights are performing well here. Now we have used ablation study because the feature vector is 100 length. So we wanted to reduce it to 20 because we want to run the system into in low performing devices also. So we have used PCA and TSNE for the feature reduction technique. The performances after the feature reduction is analyzed also. You can see here it is for the PCA. So these performances are somewhat reduced but not that much. And also TSNE. So TSNE is performing better than PCA here, but not that much. But yeah, it is better than PCA here. Now it is our system architecture. Now first the text, just a minute, pointer option, highlight. Okay. You can see here, like, sorry, just a minute. Arrow is fine. So okay, so there is a text will be passed to the phrase identification module, or then it will be there is also word to vec embedding which will go to the classifiers, 5 classifiers, and also there is the text will go to the LSTM. Then we will apply ensemble in it, and then we will give a final output to this. So this is our system architecture. Now conclusion and future work, that is, we have developed a state-of-the-art tool to process unstructured medical text, but in future we can increase the data set as well as the classes for better performance. So we can increase the data set because we want to make our system generalized so that we can use it anywhere. So these are the references which we have read before that paper. So yeah, then thank you for giving me the opportunity to present.